Many applications are more read intensive than they are write intensive. What's interesting though is we often persist data in a way that's optimized for writes. This can make querying and composing data not only more challenging, but intensive at runtime. So what's the solution? Materialized views. Let me explain different ways of creating them, and of course, the trade-offs. Hey everybody, it's Derek Comartin from CodeOpinion.com. Welcome back, hopefully. If not, and you're new to my channel, I post videos on software architecture and design, so if you're into those topics, make sure to subscribe. This video is brought to you by EventStoreDB, the stream database built from the ground up for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. Now, regardless if you have a write-intensive or read-intensive application, there's likely hotspots within your application that are read-intensive. And it's not usually something where you just have to get one piece of data. Usually you have to fetch multiple different pieces of data from, even if it's that same data source itself, but within it, this could be an event stream, a collection, a table. You have to query or join all this data together and compose it in some meaningful way that you can return to the client. And this can be even more difficult if your system is decomposed into different services where you'll likely have some gateway or backend for front end that has to interact with some API to get data out from multiple different services and then compose that data to return back to the client. It's not as simple as that first example where you have a single database. Now there's a couple of challenges here. The first obviously is just programmatically as we're writing this, understanding all the data that we need to fetch from different services or data sources. But beyond that, at runtime, the intensiveness and the load that we're adding on all these different services to compose this data, especially if this data isn't overly volatile. We're doing a lot of composition, a lot of intensive work at runtime when the data isn't changing all that much. So one solution is creating a materialized view. And the way I like to think of this, instead of having to make multiple requests to different data sources or services, I want to make a single request. That means I want to have, when a request comes in from our client, from our API, I'm thinking about a data source that has all the data that I need, meaning it's optimized for the query that I want to perform. Now you may be thinking, well, why not just use a cache? Well, this is a cache. The difference is, instead of caching our underlying data source directly, rather what we're doing is we're caching that transformation, that composition we had from multiple different data sources, and turning it into a structure that's optimized for our query. And essentially we're creating a cache from that. So as an example, let's say we have a relational database, a prototypical here of an order and order line items. So we have two orders, and our table below that is for tracking the items that belong to an order. So for order ID 1, we have two items here, and our total price of our order would be 35. Our second order, the total price would be 24. Now, if we had some type of query, some type of UI that need to list out all the orders and the total price, what we would do is likely select and join and sum the total together. Now, again, this sounds trivial, but think about a more elaborate example. In this case, what we really want is we just want a view that provides this exact query. We don't want to have to join. We don't want to have to sum. Depending what our use case is, we may just, because once this order is placed, this data isn't changing. The price, the total price is the price. Rather, what we'd want to do is just have a simple query that provides exactly this: the order ID, the customer ID, the order date, the total. Maybe there's more to this. Maybe it actually contains the customer name as well, so we don't have to compose more data. Everything would be contained into a single table. So how would we create this materialized view? The first thing is that we don't necessarily need to recreate it or think of it as two physical things. We don't need to have this view separately as a separate table. It was really just the total that we cared about. There's nothing stopping us from using that existing table that we have and having our first three columns, again, that were for write purposes, but having columns that we compute ahead of time for query and for read purposes. Now, a way we can accomplish this is with CQRS, even though we're using the same underlying data source. This means when a client requests a command to make some type of state change, we can perform that state change. And if it's even within the same table, we can do that pre-computation and persist it as well. Maybe it's a separate table that we persist within the same transaction, but we're doing that pre-computation that's specifically for our read side, for our queries. So when we have a request from our client to perform that query, it can be optimized immediately to hit the relevant data that table or tables that are optimized for your reads and potentially also for your write. Now, one of the trade-offs and things to think about if you're going to do this is that you're now mixing the write and read concerns a little bit because you have that pre-computation happening at the same time. This means that you could be adding latency and processing time when you want to perform that write, especially if it's overly complicated or intensive. If you have an exception when doing that pre-computation for your read side, if there's some type of failure, then your write, your command will fail as well. However, you'll be fully consistent with your writes and with that pre-computation for your reads. Another option is moving asynchronously using an event-driven architecture. That means that when we have a request come in for a command to perform our state change, we can write to our primary database, and then what we can do is generate an event and publish that to a topic on our message broker, specifying indicative of what that event was, what happened, what changed. From there, we can have a separate consumer that's on our query side that consumes that event and then does that pre-computation to update our optimized read database. From there, when we have a client that makes a request, it hits our query side, it just goes directly to our read database, which is optimized for that query. Now, a key thing to point out is that these don't have to be physical boundaries, meaning that that write database and read database don't have to be physical different databases or physical different tables or collections, etc. Just like my earlier example, it still could be when that event is consumed, it's just updating the existing table that's also used for the write, but just has columns or properties that are explicitly for the query for the read model. Now, what are the trade-offs? Well, the first that people will immediately notice is the eventual consistency, is that we're gonna have some lag from when we consume that event and when we do that pre-computation to then update our read model. So when you perform your write, if you immediately try to query the read database, you may be in a different state, you may be stale. Now, the second one that may not be as obvious is that if you have any type of issues where you consume events or you can't consume an event, you can be completely inconsistent. Not that you're stale, not that you're eventually consistent, that if you don't process every message successfully, you could be in an inconsistent state. Now, if you're familiar with event sourcing, this is where it actually has a leg up on that situation because your events are persisted in your event store and that's your point of truth. That means that when a command, some type of operation to perform some type of state change, you're persisting your event to an event stream. Then separately, you have a projection that's consuming that event, that's pulling it off your event stream. There's different subscription models, and it's the one doing that projection and updating your read model. And then just like before, you have your client make a query that's interacting with that read model directly. You're not necessarily using a message bus for this because within the same logical boundary, you can be using your event store because it's the point of truth and it has all the events. So a real common scenario is for reporting purposes, where you want to consume events from many different services and you want to have a query, a read database that's optimized for reporting. So let's say it was something to do with sales and purchasing, maybe gross margin. We have them publishing events and we have this reporting services that can consume these events and then build out that materialized view, that reporting database. Now you'll notice here that I put stream, event stream. I didn't put message broker or queue-based broker. And that's because you want these messages, these events to be in a log that's non-destructive that you can keep it in case you need to replay and start from zero again to rebuild out that reporting database. Again, it's really just like a cache and we need to be able to rebuild it. As I mentioned earlier, in the queue-based broker approach, if you fail to consume a message and then you just continue on, well, now you're just inconsistent. You need to be able to replay and get to the point of truth of what those events are so that you can be able to rebuild what your reporting database or whatever read model is. So if you have a read-intensive application, or really more so, you have hotspots that are read-intensive, you have options of creating a materialized view and different ways of doing it. You can create it synchronously and be consistent with both your pre-computation read model of what you're creating, as well as your write. And remember, this isn't necessarily has to be something physically separate, meaning a physically separate database. It can be the same exact table like I illustrated, or a collection or event stream that you're performing your write with as well. Now, if you move to something asynchronous, you're gonna have to deal with eventual consistency, and that has its own issues. I have videos on this. I'll provide one on the link in the description, but as well as realize that you want consistency and not to be completely inconsistent. You need to be processing the events. And if for some reason that you can't process the event and you need to rebuild, how are you going to do that? Can you do it with strictly from the events, or do you need to go back to the point of truth to get the data as a starting point? If you have questions or thoughts around this topic, you can get access to a private Discord server. You can chat with other software developers by joining my channel. The link's in the description on how to join. If you found this video helpful, please give it a thumbs up. If you have any other thoughts or questions, make sure to leave a comment. And please subscribe for more videos on software architecture and design. Thanks.